Problem 9. James leaves school and walks 3 miles to the comic book store. He shops for a comic book, then walks 3 more miles to his house. Circle the graph which best depicts the story. So in order to understand these graphs, first we need to look at the axes labels. In all three cases we have time on our x-axis as our independent variable, and our dependent variable is distance traveled. So the way the axes are labeled is always very important. We don't have titles. These graphs should have titles, but they're missing the titles. But we know that the graph is showing us how far James walked as time passed. Okay, so he left school and walked 3 miles. So in each case it's showing that as time is passing, his distance is increasing. So they all look the same as far as this first walks 3 miles to the comic book store. They all look the same. Then he shops for a comic book. Well, if he's shopping for a comic book, he's in the store, he's not moving, his distance isn't increasing. So we should have some amount of time that passes when his distance remains constant at 3 miles. And C is not showing us that, so we can rule out C. After he's done at the comic book store, he walks 3 more miles to his house. So the question is, should the distance decrease as it shows in A or increase as it shows in B? Well, the axis label is what answers that question for you. It says distance traveled. It's not distance traveled from his house, it's just distance traveled. So if he's walking 3 more miles home, his distance traveled would increase by 3 more, and answer choice B is the best graph. Number 10, which of the following gives you the next number in this pattern? Let's not even look at the answer choices. Let's just look at the sequence. We start at 0, and the next number is 5. The next number is 10. Next number is 15. Next number is 20. What's happening here? They're increasing by 5 each time. So let's look at the answer choices. Answer choice A says multiply the previous number by 5. That never works. If we multiply the previous number, 0 times 5, we get 0, not 5. If we multiply 5 times 5, we get 25, not 10. Okay, answer choice B says add 5 to the previous number. That's the correct answer. If you add 5 to 0, you get 5. If you add 5 to 5, you get 10. If you add 5 to 10, you get 15. And you could just go through all the different answer choices until you find the one that works with the sequence given. Number 11, complete the table below to convert from yards to feet. Then graph the data from your table. Be sure to include all elements needed for a good graph. They gave us 1 yard equals 3 feet, 2 yards would be 6 feet, 3 yards would be 9 feet, 4 yards 12 feet, and 5 yards 15 feet. So what do we need to show in this graph? We need to show that yards are our independent variable on the x-axis. This is yards. And feet are shown on the y-axis. That's our dependent variable. Okay, and we need to, it says all elements. We also need a title for this graph, and we said it should be dependent feet versus independent yards. Feet versus yards. Okay, now our yards go from 1 to 5, so I can just show each line is 1 yard. And our feet go up to 15. We're not going to be able to fit 15 on this graph going one at a time, so let's just go by threes. 3, 6, 9, 12, 15, 18. So at 1 yard I have 3 feet, 2 yards I have 6 feet, 3 yards 9 feet, 4 yards 12, and 5 yards 15 feet. If I connect these dots, you see that we have a straight line. So that shows that our graph is linear. The relationship between yards and feet is linear. Okay, we'll pick up the review with problem 12 on the next video.